Alright guys, here we are taking a look at our project, okay? Our math models project. I believe that's what I've called it. And it's not too difficult. And hopefully you're getting this done before our benchmark so that you can be ready for that benchmark, because the same kind of stuff will be on it. Alright, so the first thing you need to be able to have is you need this information. You need 4 of these, okay? So there's you should have 2 pages which with this graphic on it on either side. So that gives you a total of 4, because you're going to end up having 4 sequences that you're going to do this to. Okay, I'm only going to show you one example, and I'll pick the hardest type to show you guys, but you're going to have to do all the other ones too. Okay, so if you don't have this, head over to my website. That's my.uen.org/myuen/221804. And if you go to the Math 1 tab, I should have a PDF that you can print this off if you don't have it. Okay. Similarly, you also need to have signed up for some data. Okay. So, and I've got those that have been completed should be up on my website as well. So if you need to access that because you lost it or forgot it, you can take a look. So everybody will have a set of 4 sequences. Okay. And the way they're set up is, I believe, every first one, okay, is going to be in arithmetic, and it's going to be growing, increasing. The second one is going to be arithmetic, but it's going to be decreasing. The third one's going to be geometric, but it'll be increasing. And then the fourth one should be geometric, but decreasing. Okay. So, like I said, you should end up with all of those. So again, arithmetic increasing, arithmetic decreasing, geometric increasing, and geometric decreasing. Okay. So I've got here my sample ones. Okay. So again, remember with sequences, to find the start number, you always go back, because these are always the first terms. Okay. Then you just figure out how they're growing. Okay. In my case, I would be adding 7 each time here. On this one, I would be subtracting by 19. Here I am timesing by 8. And then this one I am doing division. And I'm going to hold on to that one for a second, because that is the one that I'm going to show you guys. That's the one example I'm going to do. You guys are going to do all of this 4 times for each of these cases. That's why I said you needed 4 of those pages. Okay? I wanted to show you. Okay. So the relationship info, I need to figure out where does this start and how is it growing. Okay? So if I look here, okay, how is this growing? If I wasn't sure how it was growing, I could grab a calculator and I could go, okay, first if I thought it was arithmetic, I would go 168 and I would subtract 504 from it. Okay, so I take this guy, subtract the first one, that's negative 336. So that means if it's arithmetic, I'm subtracting 336 each time. I can probably notice right here that that is not correct. Therefore, it is not arithmetic. So I want to check to see if it's geometric. And it'll either be arithmetic or geometric. You don't have to worry about the neither. So I go 168, and I can divide by 504. That gives me 0.333333333. Okay? In other words, as a fraction, that's 1/3. So my growth, as I go from 504 to 168, I'm timesing by 1/3. Now, a lot of you in your patterns are going to realize that you're dividing, and you may say, oh, I'm dividing by 3. Okay, that's all right for your growth to say dividing by 3, but eventually, with the explicit equation, you're going to want to think of it in terms of timesing by 1/3. Okay, so then my starting point, okay, so I'd go backwards, so I'd take 504, times it by 3, so my starting point is 1,512. Okay, so probably the easiest thing for you guys to jump into is the table and the explicit and recursive equations, so we'll do those first. So my table, now I can write my equations in multiple ways, so same with my table. I can choose n and a sub n. Okay, that's one of my options. I can choose X and Y. That's another option. I could even write in what two things I'm dealing with in my story or my context. Okay, that's great too. Or I can even do X and F of X. So I'll write probably the two that we'll see the most of, N and A sub N, and let's go X and Y. Okay, and that looks like two X's, doesn't it? There we go. All right, so I like to start with my beginning number, which for my term, that's my 0 term. And now we found out that it's 1,512. Okay, then my first term is 504, because sequences always generally start with their first term. Second is 168. Third is 56. Fourth is 18.6. That's 18 and 2/3 if I was going to do fractions, or 6 repeated. Okay, then my fifth and my sixth term. Let's see if we've got those. So, if I take 18.6 repeated and divide that by 3, I get 6.2 repeated. Then I divide that by 3, and I end up with 2.074. And that's actually repeated. Okay? And so there's my table. Okay? So now let's move on to my recursive equation, because that one's generally pretty easy to deal with too. So I'm going to go a sub n equals a sub n minus 1, because I always do that with the recursive, and I also do a sub 0 with my recursive. Well, my starting, my a sub 0, was 1512. My growth is, I can write dividing by 3, or I can write timesing by 1/3. Because most of you will probably write dividing by 3, I'll leave it like that. Okay. Then my explicit equation, I go a sub n. So remember, recursive, this stands a sub n is the next output. A sub n minus 1 is the previous output. And then I divided by 3. And a sub 0 is where we began. So then a sub n is my output, but with explicit, we connect it with our input. So I use my start number, then now here's where the problem's going to come. If I write dividing by 3 to the n power, that's wrong. We can't write it that way. That's where I have to write it 1/3 to the n power, timesing by 1/3. When we do explicit equations, we're always multiplying. So that's why I have to go times 1/3 to the n. Okay, now, with my equations, if I didn't like the a sub n stuff, I could write it differently. I could go y equals 1512 times 1/3 to the x. Okay, that would work just fine. I could also go f of x equals f of x minus 1 divided by 3, and f of 0 equals 1512. I'll leave that up to you guys how you want to write those. Just remember that with the explicit and the recursive equations, there are some different ways that we can write that. All right? Okay, now for the graph, I'm going to have to make my graph, okay, which I know some people may not like that, but depending on the problem, we sometimes want to adjust our graph. Because I have such big numbers here and smaller ones here, I'm going to want my graph to look more like that. If my numbers were more equal, okay, maybe I'd make my graph more like that. And by all means, you can try to graph this online with something and take a screenshot, print it out, and paste it here. Okay, that's fine to do as well. All right, so I've got to get clear up to 1,500. Okay, so let's call this 1,500. Okay, so then if I did counted by, kind of cut it into thirds, this could be 500, and this could be 1,000. This, right? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This is my x or my n. This is my, so we want to label things, y or a sub n, right? Output, input, output, input. Okay, so let's see. That's counting by 100s. think that'll give me enough information to be able to work with here. So, 0, 15, 12, so it's slightly above 1,500. Then at 1, it's slightly above 500. Then at 2, 168, so about 1.5 tick marks. 3 is 18, and then they're going to get really close. 3 was 56, and 4, then 5, then 6. Are all really close to the x-axis, but not touching it. Okay, so then I can, if I want to, oh, that was horrible. If I want to, I can leave it as dots, or I can connect the dots and make a graph like that. Either way works. I'm good with either one. Okay, but there's my graph. Okay, so again, for all 4 of your types, you're doing this, right? You're doing the same process for each one of those. Okay, you'll just have different starting points, different growths. So your explicit equation could be plus something times x, plus something or minus something, or times something, starting number. Okay, all that will be different according to the sequence that you're given. Okay? And if you have a specific question, always feel free to come in and talk to me about it. All right, now the story. Now I got to come up with a cool story that follows this starting point and follows my growth. Okay? All right, so let's say something like, let's use Adrian. So Adrian likes to, what should Adrian like to do? To make sure students listen to Mr. Rydalch. Okay. So he checks all my classes. So he sees in this first term 1,512 students aren't paying attention. Okay. Students, and I'm going to run out of space probably. And apparently I can't spell students. Let's try that again. Not paying attention. Okay. So what is he going to do? Well, he yells and yells and yells and yells and yells until, oops, didn't spell until right, until only 1/3 of students aren't paying attention. He repeats this every term. Okay? Obviously in our school we have more terms, okay? Now, we have some decimals in there. Those may be hard to understand, but maybe that would be like a student pays attention part of the time, but some of the time doesn't. So it's a student's kind of partial paying attention. Okay, but something like that. Okay, then our picture, we need to draw something cool. All right, so for my picture, okay, so we've got Mr. Rydalch being super awesome. Obviously, I'm a very excellent artist. My eyes look kind of weird. Maybe that's how they really look. And I'm teaching. La, 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 la. Okay, and then we've got students here. And obviously, I'm not going to do 1,512 because they would be in different classes, right? So I'll probably put like, because that's such a big number. So on the bigger numbers, if you need to kind of just represent them differently, that's okay. Okay, so these students are not paying attention. Okay, so that's where we started with. Okay, then term 1. So you've got me still teaching apparently I'm wearing the same clothes and a hat. Okay, and what does he do? Okay, he yells until only 1/3 aren't paying attention. Man, I picked a really difficult one to show by drawings, didn't I? So here's Adrian. Put some clothes on him. And this is yelling. Okay. And what I would, ideally show is that his yells are only reaching 1/3. Okay. And that 1/3 still isn't paying attention. And then I would do term 2, and I do the same thing, that his yells are only reaching so many. Okay? Hopefully you pick better story problems that will allow you to draw your pictures better. But that gives us a general idea of kind of what's happening here. Okay? All right. So that's kind of the gist of the main point. Then once you get a whole thing finished, okay, with that added piece, okay, right here. So then I want to kind of highlight. Oops. Oh, looks like I did make a bunch of different versions of these. So as you can see, I've got 4 different versions of them. But I'm only going to do one example because that's enough for you guys to do the rest. Okay. So then I want to take a look and try to highlight all the starting points. Okay. So on my explicit, and since it's the same color, okay, I can see where all my starting points are seen. Okay. All right. That y-intercept right there. Okay. So I can go through and see, okay, that's where all my starting is happening. Okay. Then for my growth, okay, the timesing by 1/3 or dividing by 3, okay, we can see right here. We can see it as I times by 1/3. Okay, going down. I can see it right here. Okay, I could see it, 1 out of 3 that remain. 1 out of 3 that remain. Okay, the graph is probably the trickiest one, especially with geometric. With arithmetic, it's pretty easy because it's similar to the slope. But what I can show on the geometric from point to point, if I was really good and able to, I could see that this line, this distance here, is 1/3 of this distance, and this one's 1/3 of that distance, and so on. 1/3 of each one. That's kind of how you see it in the graph. Okay? So that hopefully helps a little bit with the geometric. So hopefully you guys can see everything that we're supposed to do. And you can get your stuff done and be good to go. All right?